The functions are, these are the expressions involving some variables and dependent variables and independent variables. So if you go in the history of the function, then you will see functions, the concept of function was developed after in 17th century, after development of coordinate geometry, which is also called analytical geometry. So in analytical geometry, the concepts of geometry, pure geometry and algebra were fused, so that the properties of geometric shapes could be explained analytically and their graphical representations were possible after development of concept of functions. Function, the name was initially suggested by Leibniz, a German mathematician. He used the name function in a letter written to Bernoulli. Thereafter, this use was started. Bernoulli started to give his own definition of function, and he said that it's an expression involving a variable and some constants. Later on, the definition refined, evolved, and presently the simple meaning of function is the function is a rule by which a dependent variable is connected with independent variable. So with the help of this rule, a certain value are assigned to function based on arbitrary values of independent variable. So let us take an example. Function is denoted by fx. It is denoted by x, fx. Fx is some expression involving dependent variables. For example, say x. So just write a simple function x square plus 1. It's a function where this function will attain certain values based on this rule. When we will insert a value, suppose x is equal to 1, the function will attain a value which is denoted by f1, and this f1 will be equal to, it will be calculated based on this rule. So f1 is 1 square plus 1 equal to 2. So function is just a rule by which we find the values for certain values of dependent variable. So we will learn here how to draw a function. So drawing a function is the visualization of function. To visualize the function, we draw in Cartesian coordinates so that its property and its shape can be visualized. So for example, just take a simple function. We will draw the simple function. Let fx is equal to 1 by x. This is a simple function. So how to draw this? What are the rules to draw this function? Just make the coordinate axis, say this is x axis, say this is y axis. So this fx is also called, represented as y is equal to 1 by x. So make a table, put the values of x is equal to 1, 2, 3, 4. Then you will see the values of y are 1, 1 by 2, 1 by 3, 1 by 4, and put the values of x minus 1, minus 2, minus 3, minus 4. Then you will find the values of y minus 1, minus 1 by 2, minus 1 by 3, minus 1 by 4. So to draw the functions, we find some points. When we join these points, we will get the approximate shape of the function. So let x is equal to 1, 2, 3, 4, and here this is a minus negative direction, minus 1, minus 2, minus 3, minus 4. You see the value of y, when value of x increases, numerical value of y decreases. See, the value x is increasing and the value of y is decreasing. Similarly, value of x is increasing in negative direction and value of y is also decreasing in negative direction. You can draw the function as the value of x decreases, function is very high. Before it is less, as it, see, this is the origin. So it will be the probable approximate shape of the function in first quadrant. See, this is the 1, let this is the 1. This is the point 1, 1. This is the 2. This is the 2. So this is the point half. Value of y is half. So this point is 2, half. Similarly 3. This point is 3, 1 by 3. Similarly 4. This point is 4, 1 by 4. So you see the value of x increasing and the value of y is decreasing. Similarly, when value of x decreases, value of y or the value of function increases. In this third quadrant, the similar form you will get as the value of x increases in negative direction, value of y decreases in negative direction. So these similar points you can draw. Minus 1, this point is minus 1, minus 1. This point will be minus 2, 1 by 2. Similarly minus 3, 1 by 3, and minus 4, minus 1 by 4. So here we have drawn the function by finding some points. These points have been derived by giving arbitrary value to x, then calculating corresponding value based on the rule 1 by x. This is the 1 by x, it's a rule. Based on this rule, we attain value of function by 1, 1 by 2, 1 by 3, 1 by. Then these are the combinations of x and y. These are the points which will lie on the function. So we have joined these points. After joining these points, we got the approximate shape of this function. So these are, you will also see that no matter what is the how large the value x attains, the value of function is never equal to 0. It's never equal to 0. As the x value of x increases, value of y decreases, and when it reaches to infinity, it tends to infinity. That we will discuss in later chapter, in chapter of limit. What is the limit and what does mean? That does it mean to tend to infinity or tend to some particular value? So the x and y axis are those lines which are never touched by these curves. This curve only tend to touch this axis, but for any finite value of x it never reaches up to x or never touches the x for any finite value of x. How large it is, no matter how large it is, but it will never touch it. So such lines which never touch the particular curve, and curve always tend to incline or tend to touch those lines, these such lines are called asymptotes. So here x and y, which are the lines x is equal to 0 and y equal to 0, they are asymptote of this function, which are never touched by the function, but function tries to touch those lines as the value of x enters in limiting conditions. Limiting condition, either it tend to reach 0, then it will touch y-axis, or it tend to reach infinite, that it will touch x-axis. So we know we will never attain the value x equal to infinite, or the value of x when it will be 0, this function will be undefined. So it will never happen, then this curve will touch it, but it tend to touch it. So these lines are called asymptotes. We will take another function with simple nature. Fx is equal to 1 by x minus 2 square. This is also function, it's a rule. By this rule we get certain values of function for each individual and specific value of x. So let us draw this function. The x-axis, the y-axis. So we know that for x equal to 2, this function is undefined. So let us draw a line, x is equal to 2. Now you see, put some values of x. X is equal to 3, 4, 5, 6, more than 2, and x, find some value x which are less than 2. X is equal to 1, 0, minus 1, minus 2. For x is equal to 3, y is 1. For 4, it is 1 by 4. For 5, it is 1 by 9. For 6, it is 1 by 16. So these are the values of functions which we are getting by this rule, which is called function. Similarly, for these values of x which are on the left side of this line, for x equal to 1, y is equal to 1. X equal to 0, y is equal to 1 by 4. X equal to minus 1, y is equal to 1 by 9. X equal to minus 2, y is 1 by 16. So this is the origin. So we see as the value of x increasing, value of y here also decreasing. And when the value of x decreases, value of y increases. First thing. Second thing, you can see all values of y are positive. Whatever we select the value of x, positive or negative, because there is a square, so y will, function value will always positive. So two things are clear. First of all, function will lie on the upper side of x-axis because it is not 0 for any value of x. Second thing, it is not defined for x equal to 2. Third thing, these lines are not touched by the function, never touched by the function. So the probable shape of function is this. This shape you will attain by locating these points and then joining these points 3, 1, 3, 1. This is the 1 point. Second point is 4 and 1 by 4. This point is 4, 1 by 4. This is 5 by 1 by 9. 5 by 1 by 9. 6 by 1 by 16. So you have joined these points, you got the function, this part of the function. Similarly, for x equal to these values, for x, you will get such these values of y, and corresponding points are 1, 1, 0, 1. It will cut the y-axis at 0, 1 point. Sorry, 0, 1 by 4. This is the point. Similarly, minus 1, 9, 1 by 9, minus 1, 1 by 9. This is another point. And minus 2, 1 by 16. Minus 2, 1 by 16. So, we have selected some points, located these points on this Cartesian coordinates, and then joined these points by approximate lines. So, the approximate shape of this curve can be drawn. The shape of curve will be more and more accurate when you will find these intervals lesser. When you will decrease the interval between these values of x, you will find closer points. For x equal to 3 and 4, suppose you calculate value y for 3 point, x equal to 3.5, or you calculate y x equal to 3, 3.1, 3.2, 3.3, 3.4. As you will decrease the values of x, you will find the closer points and more accurate shape of this curve. So that's the way a function is visualized. It can be analyzed visually in this Cartesian coordinate system. These are further, as discussed in earlier graph, these x equal to 2 and x-axis y equal to 0. These are asymptote for the curve. This curve will never touch these lines, but the limiting values of x, when x tend to minus infinity, when x tend to plus infinity, this tend get closer and closer to x-axis. Hence, x-axis is asymptote for this curve. Similarly, x equal to 2 line, when this value of x reaches 2 from right hand side and from left hand side, the curve get closer and closer to this line x equal to 2. Similarly, x equal to 2, a line is also an asymptote for this curve. So this is the way a function is visualized, is drawn in Cartesian coordinates, and it is properties of shape of this function are analyzed. Another class of function is polynomials. Another class of function is polynomials. These are very famous functions. A polynomial function is in the form of a x to the power n plus b to the power n minus 1, c x to the power n minus 2, and so on up to plus constant k. This form of functions are called polynomials. So polynomials, and the maximum degree of x is called the degree of polynomial. So this polynomial can be written in terms of its roots, x minus alpha into x minus beta into x minus gamma and so on equal to 0. So based on the degree of the polynomial, there will be similar number of roots for a polynomial. If the polynomial has a degree n, it will have n number of roots. What are these roots? These roots are points on x-axis where this function touches the x-axis or crosses the x-axis. It may touch or it may cross. And the polynomial attains one of the value equal to roots. So we will see when it will touch and when it will cross. See, for example, fx is equal to x minus 2 square into x minus 1. There is a rule of multiplicity of the roots. Multiplicity of the roots, how many times that root is repeated in a function, that is called multiplicity of the roots. For example, here x equal to 2 is a root of this polynomial, and this here square is, so this root x equal to 2 has multiplicity equal to 2. Similarly, x equal to 1 is also a root, but here it has only multiplicity equal to 1. So this is called multiplicity. Suppose x minus 3, 4, power 4. So this whole function, we will say roots of the functions are x equal to 2, x equal to 1, x equal to 3, and multiplicity for x equal to 3 is 4, for x equal to 1 is 1, for x equal to 2 is 2. Now there is a rule for polynomial, when the multiplicity is even, then it touches the x-axis. When multiplicity for a root is odd, then it crosses the x-axis. So here you will see x equal to 4, this is an even number. So this x equal to 3, at this point x equal to 3, the function will only touch the x-axis. For x equal to 1, multiplicity is 1, which is odd. At 1, x equal to 1, this will cross the x-axis. Similarly, x equal to 2, multiplicity is even, so it will touch the x-axis. Okay, so you can see the function will be like this. Here it will touch, just touch, and again it will touch x equal to 3. So based on the multiplicity of this root, it will whether it will touch or it will cross, it is determined. That's the important rule for polynomial functions. Another operation of function is composition of function. Composition of function is an operation where we have two given functions and we add those functions, find one function in terms of another function. That is composition of function. So let fx is equal to x cube, given function, one given function, and second function is gx is x square. Let, just for example, these are two given functions. These are two given functions. Composite function of f and g is written as FOG. This can also be written as FGX. So here we have two rules. One rule is fx and second rule is gx. So let us find FOG. So fx, put gx in fx. F of gx is equal to x square, that is gx, and fx is cube of any dependent variable which is expressed under the function fx. So composite function is x power 6, that is FOG. This is called composite function. So this is the way we define composition of two functions. One function is written under another given function. So composition of function is by with composition operation we get another third function which can be written as composition of these two given functions. We found FOG, so it can be written as third given function which we have found as x power 6. So composition of two function is also a function which can be expressed as capital Fx or whatever you want to select nomenclature, doesn't matter. So these were some basic operations of composition of function, classification of function. The functions which we have discussed till now are called explicit functions. Explicit functions are in the form of y equal to fx. So in this explicit function, you will find function like this. Suppose y equal to x square plus x cube, etc. So this form of function is called explicit function. Here y is defined in terms of x. Other classification is implicit function. So implicit function involves dependent and independent variable in a single expression. Implicit function will comprise dependent variable, that is y, and independent variable, that is x, in a single expression. For example, we know the equation of circle in this Cartesian coordinate system. Equation of circle with origin O and radius A is given by x square plus y square is equal to a square. So this form of function which involves dependent and independent variables. Independent variable is y, x, and dependent variable is y. So both characters, both variables are involved in a single expression. So such expressions are called implicit functions. We will use the way implicit functions derivatives are derived. So that's why I just introduced you what is implicit function. Second most commonly used classification is inverse function. Inverse functions, we know fx is defined in terms of x let x cube. So we define y equal to fx equal to x cube. This is simple function, explicit function. So inverse functions, inverse function of fx is written like this. It is written like f inverse x. It is represented with the symbol inverse like this, and f inverse x has property such that composite function of f inverse with original function f. See, this is composite function which we have discussed. So original function is fx, its inverse function is f inverse x. The composite of f and f inverse is always equal to x. That is the property of inverse function. So how will we find inverse function? For example, fx is equal to x cube. Y is a dependent variable which is defined with this function, which is equal to x cube. That is very simple function. So inverse function, to find inverse function, we will find x in terms of y. Find x as a function of y from original function. Original given function, find, we have y in terms of x, so just find x in terms of y. So from our function, x is y over 1 by 3. Now replace x and y here. First step, find x in terms of y from original given function. Second step is replace, interchange x and y. So this is y is equal to x 1 by 3. This function is called inverse function. Inverse function of original function. So we will find composite function f o f inverse, which can be written as f inverse x. Original function f, which is in terms of f inverse x, and this will be f inverse x is x power 1 by 3 and fx is x cube. So f of f inverse is x. That is the property of inverse function. So how will you find inverse function? See the given function. First step is find x in terms of y from the given function. Second step is interchange x and y. So y equal to x power 1 by 3. That is inverse function. After interchanging, you will find inverse function of original function. So it can be written as f of f inverse, and similarly you can write f inverse of f. That will also be equal to x. So let us find f inverse fx is equal to, fx is x cube and f inverse x to the power 1 by 3 is equal to x. So f inverse of f is equal to x. That is the property of inverse function. You can write like this: f of f inverse is equal to f inverse of f is equal to x. That is fundamental property of inverse function. So you just find, you have y in terms of x, just find x in terms of y and interchange their position, you will get inverse function. So these were about functions. Functions are rules by which a dependent variable is related with independent variable. Here y is called dependent variable and x, which we have discussed, is called independent variable. So the values which, a group of values of x is called domain of the function. If x attains these values, y is equal to fx. If x attains these values, then this group of these values is called domain of the function. Similarly, when we put these values of x in function and get the values of y, so the related set of values of y, for 1 x equal to 1 we will have some value for y, x equal to 2, x equal to 3. So this set of numbers for values of y is called range of the function. That is a convention, domain and range. Group of values of dependent variable is domain, group of values of independent variable is domain, and group of values of dependent variable is range. There are some, we will discuss some other rules of functions. See, multiplication of function with a constant k. You can simply multiply k with a function. That is the multiplication rule, and it will be a different function called, you can call it gx. By multiplying a function with a constant, you get a different function with this multiplication of constant and earlier function. Another rule of addition, two functions can be added, two or more functions can be added, and this new function, this addition will create a new function. The whole new function, let you call it hx. Similarly, functions can be divided, fx divided by gx. It will create whole new function, call it any other function, let us say gx. So these are the rules for the functions. It can be multiplied with a constant, they can be added, they can be divided. This was introduction with functions and their operation, their properties, their representation in Cartesian coordinates.